Okay, so comparing that to factor theorem, what is factor theorem? Um, the easiest way I can explain this or compare this with remainder theorem is that factor theorem, okay, is equal to 0. We use the remainder theorem to find the remainder, right? But in factor theorem, the remainder is always equal to 0. Or basically, um, an expression is exactly divisible by a function. For example, if you divide, let's say x minus 3, and let's say x squared plus 2x minus 1, your remainder is equal to 0. So basically, when you apply the function, you'll get 0 as your answer. All right. So how do we prove this? All right. So let's have some examples. Let's have example number 5. You may get your books and turn to page. Okay, sorry. Turn to page 89. Okay. All right. So let's have example number 5. Now, if you just refer from your book, guys, it won't explain much. It will show a few workings, but it jumps to it doesn't explain much. That's my concern. But anyway, don't worry because I have explained most of the steps here. All right, so let's have example number 5. So how do we apply factor theorem in sets of questions? All right, so let's have number 5. Determine whether or not x plus 1 is a factor of the following polynomials. Class, when you say something or an expression is a factor, when you see this phrase, okay, that means that it is equal to 0. The function is equal to 0. You won't be getting a remainder on this one. That's why it's equal to 0. All right. Now, how do we test this out? How do we apply factor theorem in this one? Okay. So how do we prove that that x plus 1 is a factor of this? So basically, we have our function here, x plus 1. So our function is f of negative 1. And then it is equal to 0. Again, it is equal to 0 because uh, the x plus 1 is a factor, all right? But we're still determining, okay? It should be equal to 0, okay? If it's not equal to 0, that means it is not a factor, all right? So again, the function should be equal to 0. So what I'll do here, class, is to, of course, f of negative 1 is equal to the given expression, right? And then what do we do? So we just substitute negative 1 to the x terms. That's why we have negative 1 all over here, okay? And then evaluating this one by one. So again, 3 minus 1 minus 3 plus 2 will give you 0. So therefore, x plus 1 is a factor of the function. So it's a factor of this. All right, so if your answer is 0, that means it's a factor. However, by looking at letter B, I think you guys know what's the answer, right? So using the same x plus 1, all right? So let's check if this is divisible by or exactly divisible by x plus 1. Okay, so f of negative 1 is equal to the given function. And then we are going to substitute this x terms here with negative 1. That's how I got this. So basically, when you simplify this, you'll get 1 as your answer, which makes it not a factor of the function. All right. So if it's 1, that means it's a remainder. Okay. It's a remainder. Because when you divide this, when you do this, this is the remainder. Okay. So again, it only becomes a factor if the function, when you evaluate or evaluate it, is equal to 0. All right. So most of the time, when we answer questions about factor theorem or applying factor theorem, it's always equal to 0. Okay. So all right. So please get your books. Can you please go to page okay, page 90. 90. All right. Can you please answer number 1B and uh, 1B and number 2? Okay. So for number 1, you just need to determine whether let's say 2x minus 3 is a factor of 3x squared plus 2x squared minus 7x plus 2. Again, how would you do that? So same like my example here. So you get the function from your divisor, it's 2x minus 3, and then you substitute that inside this given expression. And then if your answer is 0, that means it's a factor. If it's not 0, so yeah, basically it's not a factor if it's like that. And then for number 2, you need to try both of these functions. You will have two functions here that you need to show your workings. Okay, if it's exactly divisible by this n. For 1b, here's my answer. Okay, so obviously 1b is not a factor of the given expression, right? It's because, okay, so again, what is your function? First, my function is f of 3 over 2, right? Because again, where did I get 3 over 2? The given divisor here is 2x minus 3 equals 0, right? And then you just solve for x. So x will be 3 over 2. Therefore, your function is 3 over 2. That's how I got this, all right? It's been the same thing since remainder theorem, right? All right, so anyway, so if this is a factor of this expression, that means that our answer here should be equal to 0, right? Now let's try to evaluate this by substituting all the values of the function to the x terms, right? So that's how I got this. So I have 3 over 2 here, okay, replacing x. And then evaluating this, basically, class, you can just use your calculator for this one. And then obviously my answer is not 0, right? So therefore, 2x minus 3 is not a factor of the function. All right? Okay. And then let's have number 2. Okay. So number 2, show that x to the power of 4 minus 3x squared plus 2x plus 4 is exactly divisible by x plus 1, but not by x minus 2. So from here, class, you just need to show your workings. You need to prove that this is divisible, x plus 1 is a factor of this expression, and x minus 2 is not a factor of this expression. All right, so here's my answer for number 2. So basically, here's my x plus 1, so f of negative 1. And then when you evaluate this using f of negative 1 to this expression, okay, and then evaluating everything, you'll get 0. So you have shown your answer, right? So this is the actual answer, the whole process, right? How about if it's f of 2, right? Again, x minus 2 gives you f of 2 equals 0. Okay, so your answer here should be 0. However, if you substitute 2 here in this expression, you'll get 4 as your answer, which makes it not a factor of the expression. So that's how you just show your workings for number 2. Okay, any questions, class, for number 1 and 2? So that's how you prove that an expression, or let's say 2x minus 3 is a factor of a certain expression. Okay, so let's have another set of questions. All right. Okay, so in your book, there's not too much examples, right? Only this 2 examples here, and then that's it, right? Okay, but before I go to this kind of example, I'll discuss a few more questions from exercise 5.3. All right, so let's have number 4 here. So for number 4, let me read the question. So given that 3x squared minus 4ax minus 4a squared has a factor of x plus 2, find the values of a. All right, so what are the keywords in this question? All right, so again, if it says factor of x plus 2, that means that the function of negative 2 is equal to 0. Okay, that's it. When you see the word a factor, that means it's equal to 0. That's why all of this is equal to a 0. Okay, so basically we need to find the values of a from this expression. And how are we going to do that? Okay, so first of all, you need to begin with your function, negative 2. Okay, so it came from x plus 2. So it's equal to 0. So the function negative 2 will be substituted inside this expression, 3x squared minus 4ax minus 4a squared. And again, it is equal to 0 because it is a factor from here. All right. Now, how do we answer this? So we first evaluate this. Okay, we plug in the value of the function negative 2 here and here. And then what's next after this? We simplify. So it becomes negative 4a squared plus 8a plus 12 equals 0. Now, what happened from here to here? Where did the negative 4, 8, and 12 go? All right, so for this step, okay. So what I did here is I made the numbers smaller, just like yesterday. So I divided the whole expression by negative 4. Okay, that's what I did. So if you divide this by negative 4, obviously you'll get a squared minus 2a minus 3. All right, that's why this, and this disappeared. Okay, and then again, why did I do that? Because it's much easier for me to answer this, right? Okay, so that's what happened there. And from here, what you need to do to solve for a. So the only thing that you can do to solve for this is what? To factorize the expression, okay, or the equation. So how do you factorize this? Again, when you have three terms, what do you do here? So going back to sec 2, the only way you can factor this, since this is not a perfect square, is by guess and check, right? So negative 3, what are the factors of negative 3? That the sum is negative 2. Okay, so again, the factors of 3 are negative 3n, positive 1, and then 3n, negative 1. But which pair of this will give you a negative 2 when you add them up? Okay, so obviously it is this pair, right? So that's why this is a minus 3n, a plus 1. Okay, so the a came from here, so a and a. So here is the factored form of the expression. All right, so once you're here, basically you just need to equate both factors to 0. Okay, so solving for a, so a minus 3 equals 0, and then a plus 1 equals 0. So therefore, the values of a are 3 and negative 1. All right, so do you guys have any question for number 4? For number 5. Okay, again, your function is x plus 1, so therefore it is f of negative 1, and then it is equal to 0 because from this word, a factor, when you say a factor, that means it's exactly divisible. So that's why this is, or these are equal to 0. And then, of course, here is your expression. So what we need to do here is to just um, put this function f of negative 1 to this expression, and then we evaluate. All right, so let's go. So f of negative 1, and then this is the expression. So first thing you need to do is to substitute all these x terms with negative 1. So it becomes this. All right, so when you evaluate this one in your calculator, so this one, so this is 48 minus, how do you expand x minus 1 squared? How do you do that? So x minus 1 squared is equal to square of the first term, square of the first term, and then minus twice the product of the first and then the second term. So that's why 2 times k times 1, and then the square of the second term, this one. So your answer here is k squared minus 2k plus 1. All right, so that's how you get the answer here. So this is my answer. So k squared minus 2k plus 1, and then minus 12 equals 0. All right, and then basically evaluate this, simplify this, combine like terms. So remove the bracket, so negative k squared, and then this is positive 2k, and then 48, so this is minus 1, minus 12 will give you plus 35, okay? So 48 minus 1, because this is negative, and then minus 12 will give you 35. So basically, this is your expression. Now, what happened here? Was negative, and now it's positive. All right, so what I did here is, I basically you can divide or multiply, okay? Let me just use division. So I divided it by negative 1. And what's the purpose behind that? Because I want my k squared to be positive, all right? So I divided the whole equation by negative 1. So it became k squared minus 2k minus 35 equals 0, all right? So what's after this? So after this, you can only answer this by factorization, right? So you need to factorize this equation. So again, this is by guess and check, right? Again, ask this. What are the factors of negative 35? That when you add them, it's negative 2. So it's 7 and 5, right? But which is negative? So it's negative 7 and positive 5. That's why my answer, or the factors of this expression is k minus 7 and x plus 5 equals 0. So again, solving for k, so equate each factor by 0. So you have k minus 7 equals 0, and then k plus 5 equals 0. So doing so, your k values are 7 and negative 5. So that's it for number 5. Do you guys have any questions for number 5? Any questions, class? Again, when you see the word a factor, that's always equal to 0. The function is always equal to 0. Back in remainder theorem, it will tell you has a remainder of. You will see that phrase when it comes to remainder theorem questions. But for this one, a factor, when you see the word a factor, it's equal to 0. Okay. So that's it for number 5. Do you have any questions? Okay, none? All right, now let's go to my last example for today, and it is this one, okay? I'm going to explain this example. All right, so example number 6. So this one came from the book on page 89. So please listen, because the book didn't, explain much of the workings, okay? So anyway, in this example, the expression ax cubed minus 8x squared plus bx plus 6 is exactly divisible. That means it's equal to 0, right? By x squared minus 2x minus 3. Calculate the value of a and of b. Now, question class, how can I divide this by this? Because from our examples, it's always x plus 1, x plus 2, x minus 1, it can be 2x minus 3. But what if it's quadratic? How can we divide this? Or maybe how can we divide this expression by this quadratic, right? So first thing that you need to do here, of course, you cannot use this as your divisor for this. You need to factorize this expression to get the two factors. Basically, when you factorize this, you will get x minus 3 and x plus 1. So these are your two functions. Okay, so again, x plus sorry, x minus 3 and x plus 1. So this is x minus 3 and then this is x plus 1. So that's why you need to basically do the same thing twice for each of these functions. Okay, so first function is x minus 3 and then the second one is x plus 1. So finding for my first, I'm sorry, I haven't finished reading the question. All right, the question here is, let's calculate the value of a and b. So from here, class, you know that you're going to use simultaneous equations. All right, because you're looking for two variables at the same time. Okay, so how are we going to do this? Again, using the factors of the given expression, x minus 3 and x plus 1, we are going to find for our two equations or two simultaneous equations. So first is the x minus 3. So your function is f of 3 equals 0. Why is it equal to 0? Because it's exactly divisible. That's the word there. Okay, so we use the given expression ax cubed minus 8x squared plus bx plus 6 equals 0. So what do we do next? Same. We just substitute this to the x terms here, right? So that's why I got 3, 3, and 3 here. Okay, equals 0. All right, and then evaluate this, simplify, and combine like terms. So this is 27a, and then this is negative 72 or minus 72, and then this is 3b, and then you bring down this 2. All right, and then we combine like terms. Okay, so 27a, bring down 3b, and then what is 72? Sorry, negative 72 plus 6 is 66, right? Negative 66, but I'll put it right here on the right hand side, so it becomes positive 66. And then what did I do here? To get 9a plus b equals 22. What do you think did I do here on this one? To make the number smaller. Of course, I divided them, right? So here, divide by what? By 3. Because these three coefficients and constant are divisible by 3. So therefore, I got 9a plus b equals 22 for my first equation. Okay, so that's how I got my first equation. All right, how about for my second equation? So again, for the second equation, you're going to use the x plus 1 factor. So that is another function, right? So the function is now negative 1 equals 0. Okay, so doing the same thing like what I did here. So given the expression, I'm going to substitute in, but this time it is negative 1 because I'm doing it for this factor. So negative 1 here, and then evaluating this, and then simplifying, you'll get negative a, and then this is negative 8, this is negative b, and then you bring down 6 and 0. So if simplifying this, rearranging this, sorry, so bring down negative a minus b, and then negative 8 plus 6 is negative 2, and then transpose it here, it becomes positive 2. So therefore, here is my second equation, right? So any question, class, on how I got my two equations? Now, again, where did they come from? They came here, from here, okay? So this and this one, okay? It was quadratic, but again, we cannot use quadratic for our function. That's why this one, okay? All right, so these are your two equations. So basically, you just need to either choose between elimination or substitution method to find for the value of a and b. And then of course, side by side, these are your simultaneous equations. So what I did here is elimination method because I see positive and negative b here. So this is eliminated right away, right? So solving that using elimination method, so this is eliminated, so it's 0. So this is equal to 8a, and then when you add this, this is 24. So therefore, a is equal to 3, right? So divide by a, right? Okay, so a is 3. So good. How about b? So for b, you just choose either the first or the second one. So of course, work smart, choose the second one because it doesn't have big numbers, right? So a minus b equals 2. So and then substitute the value of a, which is 3. So it's negative 3 minus b equals 2. Therefore, b is equal to negative 5. All right, so that's it. So that's how you find for a and b on example number 6. Do you guys have any question?